In this lesson, we will solve special case equations. There are three different types of equations that we might come into contact with. The first is a conditional equation, and a conditional equation is what we've been dealing with so far. And that means that the equation is true for some value or values, but it's false for other values. So for instance, 2x equals 8 would be true if x equals 4, but would not be true for any other values. That is a conditional equation. The two we will focus on in this lesson are the contradictions and the identities. So a contradiction is something that has no solution. So if we are to solve something, and what happens is all of the variables go away, and we're left with something that is untrue, like 3 equals 0, that would be a contradiction. We would say it has no solution. For an identity, the same thing happens, except we're left with a true statement, like 3 equals 3. What that tells us is that we could plug in any value that we wanted for x, and it would always, always, always be true. Whereas for a contradiction, no matter what value we plug in for x, we could not make the two sides of the equation equal. So let's take a look at the first one. Again, we're just using our distributive property. Minus 10 on this side, no distributive property necessary. Then I'm going to combine like terms. So on the left side, I'm going to combine -1 and -10. On the right side, I get 5d plus 3. And we can see from this point that we have the exact same amount of variables on each side. But let's go ahead and take it to the next step and subtract the 5d. And when I do that, I get -11 equals 3. I have some students who even subtract the 3 and get -14 equals 0 or 14 equals 0. In any case, this is not true. So this would be considered a contradiction, and the solution set would be the empty set. And the empty set means that it's a set of nothing. You might also see that written with the set brackets with nothing in it, which is of course a set that is empty. At our next question, following all of the same steps, and you can choose to do the simplification on the right side on the same step as you distributed on the left side. I like to go ahead and do all of my combining like terms in one step. So that gives me 7k plus 18 on the left side. On the right side, I get 7k plus 18, and from here we can see very clearly that these are exactly the same. But if I were to take it to the next step, that would give me 18 equals 18, which is of course always true. So this is considered an identity. The solution set would be all real numbers, so we might see all real numbers. We might see negative infinity to positive infinity. You might see it written in different ways. Again, press pause, try both of these questions on your own, then press play to see how you did. For the first, I'm going to distribute. Then I'm going to combine like terms. On the left side, I can't combine anything. On the right side, I get 2x plus 17. Again, from here, if you want to just stop because we can see that these two sides are not equal, you certainly may. Otherwise, go ahead and subtract that 2x. I get -6 equals 17. This is clearly not true, so this would be considered a contradiction with the empty set as the solution set. On the second question, if I combine like terms, 5x and then -2x gives me x. Subtract x from each side, I get 4x equals -12, which of course means that x is -3. This would be considered conditional, and the solution set would be that x equals -3, because that's the only value that works.